So we're representing functions as power series. So let me just review. What you want to do is try to make them look like a geometric series. So sum n is 0 to infinity, and you have a times r to the n. So a is the first term, and then r is whatever you're multiplying by to generate the pattern. And then that sum is a over 1 minus r. So the goal is to make the function look like this. You want to have something over 1 minus something, and then you can write it as a series. So the goal is to make it look like this. So for this first one, we have x squared over 1 minus x squared, which is nice because it's already in that format. So this is a over 1 minus, and then this is r. So they're actually the same thing. So a is x squared, and r is x squared. And you can write it with this sigma notation if you'd like to, but they just went ahead and wrote out the first few terms. You're going to start here. So a is your first term. And then you're going to multiply by r to generate the pattern. So we're just going to keep multiplying by x squared. So x squared times x squared would be x to the 4th. And then if you times by x squared again, it'll be x to the 6th, and then x to the 8th, and on and on. And so that one is D. So it's kind of weird because A and R were actually the exact same thing, which is sort of weird. All right, so number 2, let f be the function defined by this. This is again sort of nice because it's in that a over 1 minus r format. So a is 1 and r is x. So we didn't have to like manipulate it at all. It already looks like that, so that's nice. They're asking for a derivative. So we're going to write out the function and then we'll take the derivative. So it's going to be n is 0 to infinity, and it is a times r to the n. So this is going to be 1 times x to the n. You can put 1 times whatever in there if you would like to. All right, and then when you go to do the derivative, we're just going to do the derivative of that. I believe they started all these at 1. Here, I'll talk about that in just a second, why it's 1 instead of 0. You're just going to do the derivative of this. So you're going to bring the n down, and then it'll be x to the n minus 1. And so that one is B. I don't want to have an argument over whether to start with 0 or 1. They just made them all start with 1. The thing is, if you were to plug in 0 to this, n would just be 0. So your first term would just be 0. So instead of having the series be 0 plus and then starting, they just knocked off that first term and started it at 1. So that your first, because if the first term is nothing anyway, like it's kind of silly to start there and have the first term be 0. So that's why they started it at 1. All right, number 3, Maclaurin series for a function f is given by this. So they gave us the function. What is the value of f of 3? So we're just going to plug 3 in for x for this. So that is going to make this be, or I'm going to put a 1 in there. It's 1 times, if we put in 3 for x, this will be negative 3/4 to the n. So a is 1 and r is negative 3/4. And so the sum is going to be a over 1 minus r. So that'll be 1 over 1 minus negative 3/4. So that'll be plus 3/4. So a over 1 minus r, the negatives just canceled there. So this 1 would be 4/4 plus 3/4 would be 7/4. And we have 1 over that, so we're reciprocating that. So 4/7. So that one is C. All right, number 4 is a lot of work no matter which way you do this. I have 2 different ways you can look at this. So I'm going to show you both and you can kind of decide which one you like better. They're both kind of a lot of writing. This is sort of just a nasty problem, but we'll get through it. All right, second degree Taylor polynomial for this function. So you can look at this as a over 1 minus r. So this would be a and this would be r. So we would have a is cosine of x and r is just x. And so I'm going to write that as n equals 0 to infinity, a times r to the n. So cosine is a and r is x. So cosine of x times x to the nth. And so what we're going to do is write out the second degree polynomial for cosine of x, and then write out the second degree polynomial for x to the n, and then we'll multiply them together to get the final answer. All right, so I always write out this pattern. If you're comfortable skipping it, then that's fine. I write it every single time. I know that I'm going to lose track of what I'm doing if I don't write it out. So it's the function over 0 factorial x to the 0, first derivative over 1 factorial x to the first, second derivative over 2 factorial x to the second. And it said about x equals 0, so we're plugging in 0 for all of these. So let's do cosine of x. So if you plug 0 into that, just the function, cosine of 0 is 1, 0 factorial is 1, and anything to the 0 power is 1. So that first term is just going to be 1. All right, first derivative of cosine, that would be negative sine of x. If you plug 0 into that, sine of 0 is just 0. So this term is going to just be nothing. And then second derivative, so if we do derivative of negative sine, that's going to be negative cosine. If we plug in 0 to that, cosine of 0 is 1, but it's going to be negative. So negative 1 over 2 factorial is 2. So this will be negative 1/2 x squared. All right, so this is what we get for cosine of x. And then for this part, for the x to the n, because there's an n in that, we can just generate the pattern, just plug in, start at 0. We're going to start at 0, plug in 1, plug in 2, see what we get. So if you plug in 0, x to the 0th power is, anything to the 0 power is 1. And then if you plug in 1, you're going to get x. And then plug in 2, you're going to get x squared, and so on and so forth. And so what we're going to do, we're trying to multiply these together. And you can only multiply them together up until you get a second degree polynomial. And I know this didn't sit well with some of us. It kind of doesn't with me either. You're not going to multiply every single term together because, for example, if you multiply the x squareds, you're going to get an x to the 4th. We only want a second degree polynomial. Just think of it this way. These terms actually go on forever and ever and ever. We didn't write them all out. We're just only going far enough to answer the problem. We only want to go far enough to get a second degree. All right, so I'm going to distribute this 1 to all these terms. So 1 times 1 would be 1. 1 times nothing is nothing. And then minus 1/2 x squared. And then I'm going to multiply the x to everything. So x times 1 would just be x. X times nothing is nothing. And then I can't multiply it to here because that would give me an x cubed, which is beyond where we want to go. And then I'm going to multiply the x squared. So x squared times 1 would be x squared, times nothing would be nothing. And then I can't multiply these because that would be x to the 4th. And then combining these like terms, this is going to give us 1 plus x plus 1/2 x squared. So that is the final answer. And so that one is C. And so now you're like, hey, Ms. Cole, I know you said you were going to tell us a second way to do this. I don't really like it. Well, you're not going to really like the other way either. Like I said, this is just kind of a nasty problem. It's a lot of writing no matter how you look at it. The other way you can do this is not bother with what's A and what's R. Just use this function as is and go ahead and write out the second degree polynomial. All right, so I'm not going to write this again because I have it right there. So you would evaluate this function at 0. Cosine of 0 is 1 over 1 minus 0 is 1. So that first term is just going to be 1. Plus, and then you would have to do the first derivative of this, which, I'll go ahead and do the first derivative. I'm not going to write out the second derivative because this just gets to be a whole lot in a second here. This is going to be a quotient rule. So you would have the denominator times derivative of the numerator minus numerator times derivative of the denominator over the denominator squared. And we're trying to plug 0 into that. So let's see, sine of 0 would be 0. So this entire first thing is gone. Cosine of 0 would be 1. and these negatives cancel. So the numerator would be 1, denominator would be 1. So after all of that, you just end up with 1 over 1 and x to the 1. So plus 1x plus, and then you would have to do the second derivative of this. It would be another quotient rule. It would be a complete disaster, right? But you would do that second derivative, plug in 0, and then that would go over 2, and then x squared. I think if you do the whole, actually, yeah, if you do that whole thing, if you go through that entire second derivative, you just end up with 1, because it comes out to 1x squared over 2. All right, so anyway, this is the two ways you can look at this problem. Neither one of them's fun. It's not necessarily difficult. It just gets really tedious in there. It's a lot of work for one multiple choice question. All right, and then I threw some review questions on here. A vector valued function h is defined by this. What is h prime of 1? So we're going to get the derivative, and then we're going to plug in 1. So we have to do the derivative of each of these separately, and they're both going to be product rules. So for this first one, product rule first times derivative of the second plus second times derivative of the first, comma. All right, and then again, this is another product rule. So first times derivative of the second plus second times derivative of the first. And we're going to plug 1 into all of that. So let's see. This would be 1e plus 1e. So that would be 2e. And then over here, we'd have 1e plus 2e. So that would be 3e. And so that one is D. All right, and then last one, another review question. Which of the following integrals gives the area of the region bounded by the graphs of the polar equations? And then it lists all those out. So it is 1/2 integral from alpha to beta, and then r squared d theta. That is your formula. So this will be 1/2, and you notice none of these have a 1/2 out front, so it must have canceled out with something here. So they give us from 0 to pi over 4, which you would normally hope that that would allow you to narrow down your choices, but they made them all 0 to pi over 4. So couldn't even narrow down, couldn't even catch a break there. All right, and then it's all of this squared. So what is that? 2 over cosine of theta plus sine of theta, all of that squared d theta. So let's see, 2 squared is 4, and then half of that is 2. So you're going to have 0 to pi over 4, 2 over all of this stuff squared d theta. So again, 2 squared was 4, and then half of 4 is 2. So let me see what, this is where I have trouble picking the right answer. Is it this one? Is it C? Yeah. So C for that one.